Okay, welcome to this video on factoring. This is the first of a series of 4 videos, and this one covers the introduction to factoring and the greatest common factor technique. The first thing to know about factoring is that it just means to split an expression into smaller pieces, and the pieces are called factors, so that if you multiply the two factors together, you reproduce the original expression. For example, let's say you have just the number 30. You can factor that into two factors, 3 and 10, because if you multiply those two numbers back together again, you get 30. So you'd say 3 and 10 are the factors of 30. You've probably been doing factoring for some time, maybe without realizing it. Every time you simplify a fraction, you're actually factoring the numerator and factoring the denominator, and in this case you're trying to find the same factor to factor out so that they can cancel. For example, let's say you have this fraction 60 over 90. You could take the numerator and factor it into 30 times 2, and you can take the denominator and factor it into 30 times 3, and that allows you to cancel out the 30s because 30 divided by 30 is a 1. And so that effectively cancels to the fraction 2/3. So when you simplify fractions, you're factoring the numerator and factoring the denominator so that you can cancel. So you've been doing factoring for some time with numbers. The real trick is how are we going to factor more complicated expressions, those containing variables? So just as an overview, there are basically 4 techniques that you used, and they're each applicable in different situations. The 4 techniques are factoring out the greatest common factor, which is pretty much useful for all expressions, although it doesn't always apply in all cases. It's something you should check for in every case. There's something called trinomial factoring. That's just for expressions that have 3 terms. Then there is using patterns. One of them that we're going to talk about later is called the difference of squares. And then that's useful for when you have 2 terms. And then there's one called factoring by grouping that's useful if you have an expression with 4 terms. This first video talks about the first one only, factoring out the greatest common factor. Okay, so let's talk about that. If you have a multi-term expression, the greatest common factor is the largest expression that is part of all the terms. In other words, that all the terms have in common. It's factored out to one side, and it leaves behind an expression in parentheses. The best way to see this kind of conceptually is just to think about an expression. Here we have a binomial. It has 2 terms in it. One term is 2x squared, and the other term is 4x. They're separated with a plus or minus sign, these terms. Okay, so if you think about this first term on the left, the 2x squared, it really contains a number of things that are multiplied together. There's a 2 that's multiplied by an x, and then it's multiplied by another x because it's x squared. That means 2 x's multiplied together. The second term here has a 4 and an x. So I'm going to think about the 4 as being 2 2's multiplied together, and then the x is also multiplied. So we have two x's on the left term, and we have 2 2's and an x in the right term. Okay? So we're going to look for the greatest common factor. Now the greatest common factor is the largest thing that can be that is a part of both terms, that both terms have in common. Okay? It looks like both terms have 1 2, and both terms have 1x. And that means that 2x is the greatest common factor. So what we're going to do is we're going to write that greatest common factor over on the left side. This is the greatest common factor, often abbreviated GCF. Okay, and then it's going to be multiplied by the other factor. So the other factor, we write that in parentheses because it's going to contain this plus sign, right? What it's going to be is what's left over when I remove the 2x from each term. So in the left term, I remove the 2x, and what's left is this x. And so we write that here. And then in the right term, when we remove the 2 and the x, what's left is a 2. And so that's plus 2, so we would put plus 2. And that means that this expression, 2x times x plus 2, is the factored expression. In other words, we've factored the original expression into 2 expressions, or 2 factors, sorry, and the left factor is 2x, and the right factor is x plus 2. Now the nice thing about these factoring problems is you can always check your work to see whether or not you did this correctly. So we had 2x, x plus 2, and if I wanted to check, I could always distribute the 2x, which means everything inside there is multiplied by the 2x. So I'd have 2x times another x is 2x squared, and then 2 times 2 is 4 times x. And sure enough, that is the original expression, and so that's factored out. So that's really what's going on when we're factoring out the greatest common factor. We're trying to identify the largest thing that's present in common to all of the terms in the expression we're given. Now, normally I wouldn't write it out like this, you know, separating a 2, an x, and an x, and a 2, and a 2. So let me just do that problem over again the way I would normally do it. which is to just look at the expression and say, okay, this expression has some numbers, so let's look at the numbers first. Right? There's a 2 and there's a 4, and the largest number that goes into both of those evenly is 2, so I'll start by writing a 2 on the left. And then I'll look at the x terms here. There's an x squared, which means 2 x's, and then there's another x in the other term. So at most I can take 1 x out, because the right term is limiting me to only take 1 x out in common. So I'll take that out and write that on the side. And then the way I think about what goes in the parentheses is I kind of work backwards and I say, what would I have to put here so that when I multiply by 2x, I get 2x squared? And what's missing is 1 more x, so I put that there. And then I ask, what has to go here to get a positive 4x? Well, the 2 has to be multiplied by a 2 and positive, so positive 2. And then I already have the 1x I need, so I don't need anything else. And so I have my 2x times x plus 2, the same thing as we got before. Okay, so that's basically the concept. What I'm going to do now is run through a number of examples that show different levels of complexity of the same concept. For each one, what you should do is pause the video and then attempt to do this on your own, and then the piece of paper, and then unpause the video and see whether or not you got the answer right. So you get a little bit of built-in practice. Okay, so you can pause the video here and see, based on what you've seen so far, how would you factor a greatest common factor out? Okay, here's the solution. Number-wise, all these numbers are divisible by 4, so I could take a 4 out. Then there's x's in these terms, and the right term only has 1x, so I'm limited to taking only 1x out. What I'd have left would be x squared here, because I need to multiply x squared by this x to produce the x cubed. And then to get the 4 to turn into a 12, I would need a positive 3, and then I need 1 more x in order to get x squared. So x times x leaves me x squared. And then to get an 8x from a 4x, I need to multiply by a positive 2. And so that's my answer. That's factored, where I factored out the greatest common factor, which is 4x. On the right, let's just check it really quickly. 4x, x squared plus 3x plus 2. Distributing, I get 4x cubed plus 12x squared plus 8x, and compare, and that indeed is the original expression, so that's correct. Okay, here's another example. Again, try to pause the video and see if you can figure this out. Okay, here's the solution. There's 2 terms here, separated by a negative sign, and I can take a 5 out of both, right, because both 5 and 10 are divisible by 5. There's an a in this left term, but there's no a at all in the right term, so I can't factor that out. It's not in common to both terms. But both terms contain at least 1x, so I can take an x out, and both terms contain a y, so I can take a y out. And that's it for the greatest common factor. What's left is, well, I already have the 5. I'm missing the a, so I need that. I have 1x, but I need 2 x's to be multiplied together, so I need another x, and the y is already there. So that's it for the first term inside the parentheses. Okay, I have to turn that 5 into a negative 10, so I'll multiply by a negative 2. And then I need xy, but I already have xy in the greatest common factor, so it looks like I'm done. 5xy is the greatest common factor, and ax minus 2 is what's left in the parentheses. Let's check. 5xy times ax minus 2. Distributing, we get 5 times a times 2x's multiplied together times a y. And then over here, we just multiply the greatest common factor by 2, which changes that 5 into a negative 10. And that does match. Okay, continuing. One more example. Let's see, what can I take out? I can take only an x out. It looks like there's no numbers here in the first term, and there's only one x. So at most, I can just take one x out, and I would be left with that. Let's check. Okay, multiplying out, x to the 4th plus 3x squared plus 6x, that does compare. One last one. Let's see. I could take a 2 out. The b is only present in the left term. There's only one x in common, but both y's are in common. And so what's left? I need a b here. I need 2 more x's to make an x cubed. To turn the 2 into a negative 14, I need a negative 7. And that's it, because the rest of it is already there. Double checking. So 2bx cubed y squared minus 14xy squared. Sure enough, that works. Okay, that concludes this video. For more information on factoring, check out parts 2, 3, and 4.